Okay. I think I have some stuff I can throw back. All right. So let's look at, let's play a game. Are you familiar with Mario?
Yes.
No.
Now this is before my time even. We're going to look at I'm revealing myself as an ad block person. Hopefully the government doesn't find out. Here's the original Super Mario Bros. So this guy, this was a groundbreaking game because you can move in multiple dimensions. So Mario, how many dimensions is Mario?
2D.
2D. Now, of course, you've got, Fortnite is 3D because you can go left, right, up, down, back, and forward. But Mario can only move left and right, and he can move up and down. This is 40 minutes. Maybe we'll just watch the whole thing. No. So he can move in 2 dimensions, and that's what we're looking at today. So in math class, all you guys really talk about is dimensions. So, what's the dimension on that graph that goes like this? What's the line that goes sideways in math? X-axis, and then what's this axis? Y-axis. So those are tracking the dimensions. So we're going to look at 2 different equations that we've already kind of seen before, but they mean something different when we're talking about 2 dimensions. So here's our first one. So Vx equals delta x over t. That comes from the equation we did before. The equation was just v equals delta p over t. So ignoring this for a moment, what was delta p again? Displacement. So delta x is our x displacement. It's how far sideways Mario goes. We also have the same equation but with y. Vy is delta y over t. So if delta x is our x displacement, what's delta y? Yeah, if delta x is our x displacement, what's delta y? Y displacement. Her faith too, yeah, so awesome job. So then v is velocity, vx is x velocity. Since v is velocity, vy is y velocity. So there's pretty much only one type of problem that we look at with this, and we call it the riverboat problem. So we're just going to start with that. We might do 3 or 4 of them. If we understand them after 2, well, we'll just stop after 2. So it's the riverboat problem. The riverboat problem. Basically, I'm going to ask you to find one of those 5 things. I'm going to ask you to find Vx, delta x, t, Vy, or delta y. One of those 5 values that we can find. So here is the riverboat problem. You're on a raft. Seems legit. If I put some oars on it, looks even more legit. Oh, that's worse, but you get it, I think, hopefully. So here's the river. And so what's that force that river pulls stuff with? Starts with a C, I think, or current. So the current is going to bring us down, and the actual rowing that we're doing is going to bring us sideways. And we represent that with a triangle. So maybe we'll just keep it simpler. So we'll just draw it like this. So here, this is us rowing sideways. What do you think? I'm going to draw the velocity, but what do you think? Is that x velocity or y velocity? X, because it's pointing sideways. So we'll say Vx is 3 meters per second. So we're rowing our boat. It's bringing us sideways with a velocity of 3 meters per second. But, but if the river is pulling us with current, then we'll also have y velocity. So Vy is going to be let's say it's a pretty strong current. It would be 7 meters per second. I have to add a little bit here though. We need to talk about our signs. So this is positive because it's to the right. What about the 7? What do you think that'll be? Negative because it's pointing down. Sometimes it matters, sometimes it doesn't, but we may as well talk about it there. So basically, when you have oars that are rowing you across the boat, the stream, and you have a current bringing you downstream, you're going to move in 2 dimensions. You're going to move at an angle, and then you're going to stop when you hit the shore on the other side. So this picture here represents the boat right as it's reaching the other side. So it still has the same velocity of 3 meters per second. It still has the velocity of 7 meters per second, but that's just where it ends up. So there's a couple things we can find. Let's say it takes, I don't know, let's say it's a pretty big river. Say it takes 220 seconds. 220 seconds, about a little under 4 minutes. Maybe I'm making that up. No, I think it's a little under 4 minutes. But we're going to calculate 2 things. We're going to calculate delta x and delta y. Very good. So in yellow here, this is what we're actually solving for. On an example problem, I would probably have it written a little different. I would actually write everything out. But this is just a good way to start. So to get delta x, of course, we're going to use the x equation. And we can't mix stuff. So let's just see what we can do. I'm going to write out the equation that we're using here. Magenta's not doing it. I think we need like a, more like, yeah, let's try like this neon green. So here's the equation we're going to try to use to get delta x. What goes in for Vx? 3. Very good. We just leave delta x because that's what we're trying to find. And then the time, well, time is the same for both of those. Anybody remember what happens, like, after 220 seconds, what happens to the boat again? What happens to the boat at 220 seconds? 220 seconds pass, and what happens? It's on the other side. So that's where the whole journey ends. Like, if we wanted to figure out how far across the stream we're going. Oh, forgot some? Yep. It's all good.
Thank you.
You're welcome. It's like a lot of energy. Okay. All right. Think anyone get 660? And that'll be positive 660 because we're going to the right. So to get Vy, it's going to be the same thing except -7, yeah. So to get Vy, it's the same idea. So this is probably the simplest it can get. So Vy equals delta y over t. -7 equals delta y over, I forget, was it 22? Oh, 220. Losing my mind. I cannot do that in my head. Well, maybe I can. $14.40? 15.40, dang. My answer is only partially right. I don't even know what we got to do here.
It's a negative.
Negative. So very often, if you forget the negative, you could still add it on at the end. It ends up being negative 1540, but why is it negative? Like, what does the negative mean? It's going down, yeah. Chris? Like, you mean, wouldn't we write the word down?
Like south.
You could write south or down, but negative means that. Negative also means that. So, and plus means east or north. Cool. Let's do a complicated one. All right, let's get crazy. Let's do a crazy one. So we're gonna do again the riverboat problem. We're gonna calculate them in a very challenging way. You're gonna be visited by your old friend, Sokotoa. You know what? I'm gonna stop.